Basic proportionality theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. First, triangle ABC and a line DE parallel to BC. You can observe DE intersect AB in D and AC in E. This is the given part. Now we can observe one more triangle here, triangle ADE. Let us see what are we required to prove. We need to show that the other two sides are divided in the same ratio. The other two sides are AB and AC. This line segment divides them in the ratio AD by DB, AE by EC. We need to show that these two ratios are equal. Now observe children, AD by DB is equal to AE by EC. That's what we are required to prove. For that, we need to consider triangles that have these lengths as their sides. Look at AD. Yes, we have a triangle with AD as one of its sides. AE, we have the triangle that has AE as one of its sides. AD is the triangle. Now look at the denominators DB. Do we have any triangle right now with DB as one of its sides? No. Similarly, EC. We do not have any triangle with EC as one of its sides. So to get them, let us join BE and CD. So let us join them. Now we got two triangles. You can observe triangle BDE and triangle CDE. We got two triangles, triangle BDE and CDE, that has got BD and CE as their sides. Right. Now we need to find the area of these triangles. Let us draw perpendiculars. DF is drawn perpendicular to AE and EG is drawn perpendicular to AB. Recall the formula to find the area of the triangle: half into base into height. Can we take any of the three sides of a triangle as base? Let us just check. Consider the triangle ABC, children. Its base is AB and the other two sides are BC and AC. We know that the height for this triangle with AB as base is a perpendicular drawn from C onto AB. So let us just draw it and see the same triangle with BC as base and AC as base. Observe. Yes, these three represent the same triangle ABC. Base along with their corresponding heights. Now do you think the height of a triangle always lies inside the triangle? Let us see. You can observe the right angle triangle here. You can see that the side coincides with its height as it is 90 degrees. Now in an obtuse angle triangle which has got obtuse angle as one of its base angle, its corresponding height lies outside the triangle. Let us go back to our proof. Look at the left hand side. We have AD by DB. So we will be considering the triangles that has AD as its side and DB as its sides. You can observe the triangles ADE and BDE have these lengths as their sides. Let us take these two triangles, triangle ADE and triangle BDE. Now let us draw the perpendicular from its opposite vertex E to G. You can see EG is perpendicular to AB. Now area of the triangle ADE by triangle BDE. Observe that EG is the height for the triangle ADA, and also for BDE, as you can see that BDE is an obtuse angle triangle and its height lies outside the triangle. Now let us take their areas, the ratio of their areas. Area of triangle ADE by area of triangle BDE, which is equal to half into AD into EG. For the denominator, for triangle area of triangle BDE, half into the base BD into height, corresponding height EG. Now you know very well, half and half gets cancelled, EG and EG gets cancelled. Now we will be left with AD by DB. We will be considering the triangles that has AE and EC as their sides. AE. So again we will be considering the triangle ADA, and now this time CDE. So these two triangles in step 2. So let me take these two triangles. You can see ADE and CD we are going to consider. Now DF is a perpendicular to the base AC. Again you can observe DF is also the height when CE is considered as base for the triangle CDE, as at E it is an obtuse angle. So let us take the ratio of their areas. Area of the triangle ADE by area of the triangle CDE is equal to half into AE, the base of ADE, into DF, the corresponding height. Now for the triangle CDE, half into CE or EC into the same height. It has got the same height, DF. Now half and half gets cancelled and DF gets cancelled, and we'll be left with AE by EC. Now you can just observe, we got these ratios, but we have to prove that these two are equal. Now to prove that, let us just have a look at the left hand sides of these two equations. In the numerators you have ADE and ADE, it's common. In the denominators you have triangle BDE and triangle CDE. So if we can show that these two triangles, triangle BDE and triangle CDE are equal, then it is proved. So for that, let us consider these two triangles, triangle BDE and triangle CDE. Let us take those two triangles, triangle CDE and triangle BDE. You know that triangles on the same base and between the same parallels are equal in area. Therefore, area of triangle BDE is equal to area of triangle CDE. Even the denominators of these two equations are equal. Therefore, we can say that AD by DB is equal to AE by EC. Let us write the steps properly. Basic proportionality theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Let us consider the triangle ABC, and the line segment DE is parallel to BC. Given in triangle ABC, DE is parallel to BC and D intersects sides AB and AC at D and E respectively. We need to prove AD by DB is equal to AE by EC. As we have seen the construction, join BE and CD and then draw DF perpendicular to AC and EG perpendicular to AB. Now let us start our proof. Area of triangle AD is equal to half into AD into EG. Area of triangle BD is equal to half into DB into EG. Divide these two equations. Half and half cancels, EG and EG cancels. We are left with AD by DB. This is our first equation. Similarly, for the triangle ADE and for the triangle CDE, when we take the ratio of their areas, we get it as AE by EC. This is our second equation. Now in step 3, We will be considering triangle BDE and triangle CDA. They are on the same base DE and between the same parallels DE and BC. So their areas are equal. From first, second and third equations, we have AD by DB is equal to AE by EC.